everyone. Thanks so much for coming to the webinar. We're so glad to have you with us this evening for our webinar that's about making sense of science posters, where we're really going to be focusing on how to help students translate their science experiments into a poster format that can be used for a school science fair or for the upcoming virtual science fair that Kids Making Sense is going to be hosting in the late spring. So before I jump into today's material, I first just wanted to introduce Kids Making Sense for those who maybe aren't as familiar with the program. So Kids Making Sense itself is a science educational program with a full curriculum and products that teach students how to measure air pollution using air quality sensors, how to interpret the data that they collect, and how to take action to reduce emissions and exposure to air pollution. And the program was created and is being run by an experienced team of air quality and atmospheric scientists who are really passionate about air pollution, meteorology, and climate change. And the program and its tools were developed and refined over the course of over 8 years in collaboration with environmental agencies, teachers, and community groups. And so up to this point, it's been used in over 300 classrooms in both the US and abroad. So here at Kids Making Sense, our team is made up of scientists, educators, technical staff, and today you're mostly going to be hearing from me. I'm Olivia, here in the middle. You can see me on the screen. And I'm the lead Kids Making Sense scientist, and I'm also an atmospheric scientist and a chemist by training. And back during my school days, my research was focused on understanding how pollutant gases in the atmosphere interact with particles in the air, just to give you sort of a background on where I'm coming from. And on the core team, we also have Will McCoy, we have Tammy Lovezzo, Tim Blakey, and Bryant West. And Tammy and Bryant are both going to be helping today with the Q&A section, which I'll talk about in just a second. So our agenda today, we're going to be going over really what is a science poster and how can we transform a Kids Making Sense airbeam session or any science experiment for that matter into a science poster. So we'll talk about what is a science poster, how can making a science poster really benefit students, the Kids Making Sense data map. I'll give you a refresher on what that looks like in case you haven't seen it before or in case you haven't seen it in a long time. How students can plan their poster, how to really create a poster. We'll go through details on each section and what might be included in each of those. And then an invitation to the Kids Making Sense virtual science fair at the end, and a Q&A section. So just a little housekeeping. So please use the Zoom Q&A feature to ask any questions that you might have while I'm going through the material. And Tammy and Bryant will be helping to answer questions during the session. And if there's questions that they feel need to be answered out loud, we can do that at the end. And so you'll find the Q&A feature at the bottom of your screen. It looks like two little speaking bubbles down there. Yeah, so any questions you have during the material, please feel free to write them into there. And then I should also note this is being recorded. And we'll upload it to our YouTube page, and I'll email out the link to everyone once it's available. And I can also make sure that the slides are sent out as well if people would like that. Okay, and one more thing before we get started. I just wanted to try and get an idea of who the audience is and your familiarity with Kids Making Sense and the technology. So I'm going to launch one poll, it's just one question. Does your classroom or school have a Kids Making Sense kit? And so if you could answer that, that would be fantastic. And I should note that while I'll be using Kids Making Sense and the experiment that the main experiment that we have as part of the curriculum as an example throughout the webinar, this could easily be done. You could easily use this template and the information that I'm going to be talking about with any science activity or experiment. So you don't have to be limited. Okay, that's fantastic. We have about a 50-50 split here. That's great to know. And for those who don't have a kit, I should just point out we have some links at the end of the presentation, links to our website, or you can reach out to us directly if you have questions or if you're interested in finding out more about the program and the kids themselves. Okay, so let's jump into this. So before we think about science posters, though, let's first think about science itself. So in general, if we do think about science, it's typically performed in labs or out in the world during field studies by scientists. But really, if the work stayed in those places, it wouldn't be very helpful. So who does science need to be shared with to make it as useful as possible? So you might think about this, and the first group that might come to mind is other scientists, and that's to let other scientists know about recent results that might help to build on the work of others. Second group might be policymakers who can take discoveries and translate them into new laws or update older ones. And then the third group you might think of is the general public, and that's for their own interest and also to communicate new discoveries with the general public and to also help improve society in some way. So one way that scientists are able to share their findings with their peers or with others is through the use of science posters, specifically at poster sessions during conferences. And so you can see in this top photo up here, a very large conference with just lines and lines of these science posters, basically lining the entire conference hall, just tons of people trying to share their work with others, with their peers. So a science poster is something you might be familiar with in your own life from maybe science fairs, but essentially it's a poster showing what the experiment was, the background, the work that you did, results, findings, and conclusions. And what it's doing is really telling a story of the experiment that you chose to do. And so one advantage of science posters is that the work doesn't have to be fully finished to be able to be presented in this format. In fact, I would be willing to bet that a number of people that were presenting at this conference up here, all this, the work that they were presenting was probably in progress. It was not fully finished. It wasn't written up in a journal yet. And the reason for that is that people like to get ideas or feedback from their peers or others that might have ideas when they see the work that they've been doing. And so it really enables people to be able to have one-on-one discussions with audience members, and it allows the presenter to showcase their work, get feedback, and have informal discussions or trade ideas, practice explaining their work and creating new contacts. So that was more from a scientist's point of view, but what about for students? How can this really, making a science poster really benefit students? So the first is that they can be used to present work at science fairs, which is great because many students participate in those. Students can really practice their interpretation of science and also their communication skills. They can learn how to use data to tell a story and really explain the so what of the work that they were doing, which then in turn helps them to better understand what it is that they're doing. They can learn about the work of others or their classmates from their classmates' posters. And in creating the poster itself, it allows the students to think and reflect on each part of their experiment and the scientific process, which then in turn helps them to take more away from the experience. So it really slows them down and has them think about each step in turn. So there's really a number of benefits for students. So now that we've sort of talked about why students, might benefit from making a science poster, we'll jump further into the exercise of actually making a science poster. So, okay, so if students have done an experiment, what's their starting point? So let's use the Kids Making Sense program as the starting point here. So if they were using the program, they'll have used the small handheld sensor to collect the data when they were out in the environment. Their data was then automatically uploaded to the Kids Making Sense mapping website, which you may remember looks like this. So just as a refresher, so the colored trace that you see here is showing the concentration of particles that was measured as the students were walking around. Notes that they may have taken along the way or photos that they may have taken are showing up in these blue speech bubbles. And then there's also a time series trace down here at the bottom. So you can see in terms of time and concentration, how the levels of particulate matter were changing in the air. And you can change the averaging or the period of time that you're looking at to zoom in or zoom out. Okay, so just in a nutshell that, oh, sorry about that. Let me go back one. That's just, now I've gone back too many, there we go. That's just a refresher in case you haven't seen the screen in a long time as to what their starting point will be. So they'll have taken measurements and now they have this data on this website. So now really the question becomes, okay, well, how do I now help my students take this study that they've done and create it into a completed poster like the one you see here on the right? And so again, I said it before, but I'll say it again, while we're using the AirBeam experiment as an example, this could really apply to any science experiment or another activity in the curriculum as well. It's really up to you how you want to implement it. So in the rest of the webinar now, we're going to walk through how to help your students create this type of poster here on the right in some very straightforward steps that you'll be able to help them with. And to make things easier, we've created this free template, looks just like this, that your students can use to create their poster. And it's in a PowerPoint format, so you can use either PowerPoint or you can use Google Slides to open and edit the template, or they can. And also within that same document, the same PowerPoint document, there is a second slide which has the example poster that I showed on the previous slide. So it has this filled out version and it has this template version that students can fill out themselves just to help them. If they struggle with a specific section, they can look at the sample poster and sort of get an idea of what they might put into that section. That's annoying. There we go. And then finally, if you go to the link shown here, you'll be able to download the free template and the sample poster. You'll also be able to find a link to a set of slides, which are instructions that you can provide to the students or you can use in your classroom to help guide students through each of the sections. I think this, yeah, we can just play that on the side there if it works. We'll see. So these are the slides that you'll be able to click through and you can, yeah, see them scrolling through. So it's going to be very similar to the material that we're going to go over today, but this is more in a very compact and easy to present version for students. So next we're going to walk through each of the sections of the poster and what students would want to include in each of those sections. And I'll use the sample poster that I showed earlier as an example as we go throughout. Okay, so the first step, as I alluded to earlier, is planning, which begins with really students thinking about who the audience for their poster is going to be. And so this will really also help students to frame their work. So for example, is the audience that's viewing their poster going to be their parents? Is it going to be the general public? Maybe their classmates or school officials or science fair judges? It's really a whole group of people that they might be presenting to, and it's important for them to identify that ahead of time. So once they've determined who the audience will be, they'll then want to think about how familiar the audience will be with the work that they're going to be presenting. And that's going to affect how much detail they explain certain concepts with, whether they use certain terms. You just want to make sure that there's enough detail there for the audience to understand what it is that they're presenting. So for example, their classmates might be more familiar with an AirBeam and how it works than maybe the school officials or parents. So maybe if their audience is their classmates, they might put in less details about the AirBeam. If it was their parents or school officials, maybe they would put in a little bit more of an explanation about how the AirBeam works or what it measures. And the second part of the planning process is creating an outline of the information that they want to include in the poster. So this is really important to help them craft the sections and also to think about how each section connects to the next section. And so the important part here is to emphasize that effective posters are really ones that are going to be telling a story of the work that they did. So people are able to connect with stories, they're better able to remember, and really connect with them. So if students can keep this in mind when they're making their poster, it's really going to help them craft an effective poster and effectively communicate their work to the audience. Okay, so now we're going to go into each of the sections and summarize what would be included in each one, as well as any tips that we can suggest along the way as well. So first, it probably is not a shock, is the title. So first, students are going to give their poster a catchy title that also describes what they did. So the title is the first thing that people are going to see when they look at the poster. And so students really want it to be catchy and to draw people in. And it could be a question. In this case, it's more of a statement, but it could be either one. And so a tip here is to keep the title short and sweet, because long titles, if they're taking up 2 lines, they're not going to be as inviting to the audience. They're not really going to catch someone's eye. The second section here is going to be the author list. So students will want to add the list of all the members of their group that participated in the project. If they all contributed equally, you could ask them to list them alphabetically, if that would be less controversial, or cause less fights amongst the students. You may also want them to include your name and the school or the class that they're in as well. And so next is the highlight section. And so this can be used as an area to really quickly summarize a study in 3 to 4 bullet points. And it's really to help somebody that's maybe walking by their poster to quickly digest what it is that was, the topic, what was done, maybe what a main conclusion was, something like that. It really is, it's almost a summary. And so, yeah, the topics might include what you did, any sort of key results that were found, perhaps an important conclusion from the work, but really no more than about 4 bullet points is appropriate in this sort of a section. And you could also describe this to students as sort of a summary if that would help them craft these bullet points. Now, going into more of a main section in the poster is the introduction. And so that's where really the background information on the topic would go. So for example, on the sample poster on the right-hand side here, we can see information on, they've included information on what particulate matter is, why PM2.5 is a health concern. This is also a type of section where you'd want to include or add information that would help the audience to understand why you chose to investigate your science question and help viewers understand why the work is important and relevant. So in terms of storytelling, this would be akin to sort of setting the scene and giving people enough information to make sense of the rest of the story. So again, we can see in the sample poster, they've included some information about wildfires in Northern California. They've also included a map along with a description of how wildfires can impact PM2.5 concentration in the air. And so some important points to keep in mind here is to include enough detail so that people that are unfamiliar with the topic will be able to be brought up to speed, but also to keep the points brief, but still make sure the importance of the work is communicated. So it's sort of a fine balance. You want to include enough information, but not have this take up the whole poster. And so we also know that a photo is worth 1,000 words. So including photos or diagrams here can really be helpful, like the sample poster has done. We have a map, which is very helpful to sort of describe where fires took place and sort of the magnitude of them. We also have an image about the effects of breathing in particulate matter and how that might affect, different parts of the body. And then one additional tip here is to, sorry, there we go. My mouse stopped working. One tip is to make sure that the photos that are being used aren't fuzzy or pixelated. Some of the important information might be lost if people are having a hard time really, seeing the details in the image that's being used. So that's just a small a tip that could be helpful there. So part 5 is the science question. So this one's pretty self-explanatory, but it's where students will want to explicitly write down what their overarching science question was and what were they investigating in their experiment, essentially. So we can see in the sample poster that the question was how the air quality changed when driving from the valley up a mountain during a wildfire smoke event. Straightforward, to the point, that's what the science question was. And one possible place that students might get tripped up here is remembering that their science question is not the same thing as their hypothesis. So those two could get potentially confused. But we've also included a place where they could put the hypothesis if they want in the poster. So that would be them explaining what they expected to have happen during their experiment. And I'm just going to pause here for a second. We've included all of these different sections of the poster, but there's no right or wrong way to really create a science poster. If you feel that they don't need to include a science question and a hypothesis here, you can change it. You can take those out. You can tell them to remove those sections. The template is very flexible. You can make, certain sections bigger or smaller, depending on the work that you've done with the students, or, depending on how they want to describe the work that they've done themselves. So there's really a lot of flexibility there as well. But we thought including these sections then gives you the option to fill them out if that's something that you feel you want your students to do. Okay, so the next section is then the procedure. So this is where the students are going to outline, possibly even step by step, what they did and the steps that they took in their experiment. And again, photos worth 1,000 words. So if adding a photo or an image is going to help them explain what they did, or they feel that it's going to add something to this section, then feel free to do so. So in the sample poster, we can see that the students started their experiment at home. They were driven around a neighborhood for a period of time. Then they went up a mountain. And the window was kept slightly open, and the air beam inlet was directed out the window. And you can see that they've written it in words, but then also this really helpful photo that sort of immediately shows you how they did this experiment and how they were sampling. And then they also added some additional details about how they took their notes and details on how long they sampled for and how fast they drove, which could be useful for some audience members that might have questions about that. So very straightforward, just what they did in simple steps. Okay, so then the next section is the results and analysis section. So this is where they would be including charts, plots, images, tables, all these sorts of things that show their data and their analysis. So some questions that might help sort of spur students' thinking and help them organize their thoughts for this section, especially if they did a long experiment or an experiment that had many parts to it, are, first of all, what data did you actually collect? Having them sit down and think through, okay, well, what did I actually collect can be really helpful. And then the second question is there, a section or a part of the data that's more interesting than other parts? And do they want to, focus their story on one part of their data? You don't have to, this is something that even scientists get caught up with. You don't have to show all of the data that you took. If there's a certain part that's more compelling that you want to explain, you can just show that part, and that's okay. If the rest of it's not contributing to the main story, you don't have to show it all. Okay, so including a screenshot of the results from the mapping website, like is being shown here in the sample poster, can be incredibly helpful for this section. And it's very simple for students to do. They would just go to the website. They can use the Snip and Sketch application, which is already, on most PCs. I'm sure Mac has a similar version, or you just screenshot the page and just, crop out the map where it shows the results. Very straightforward to do. And it also allows them, as is shown here, to draw, to describe what's happening at specific points on the map. So, that this is where they started to drive up the mountain. This is, the neighborhood at the bottom in the valley. It really allows them to go into more detail about what's happening in each section of their map. And if the experiment was done indoors, the map may be less helpful, but what you could do is screenshot the time series at the bottom of the page, and then they can draw the same sorts of arrows and call out different areas on the time series instead. They can annotate it out. So this is the results and analysis continued. Another set of questions that might be helpful for students when they're completing this section include sort of, how is your data best represented on your poster? Or in other words, what format is going to help you to tell a more clear story and help your audience understand your work? Because as you can guess, there's, they could show the plot, they could show the time series, they could show a table, they could, there's many ways that they could present this data. But having them think through what the best way is, given the experiment that they did, can be very helpful. And they also might want to consider including additional information that might describe or help describe or explain their results. So, for example, here we can see that an observations column was added to this table. So they've included the time that they were measuring, what the average concentration of PM2.5 was during that time. They've added location so that they can compare, okay, well, I was in the neighborhood versus I was driving up the mountain. Okay, what is the difference in the concentration? But then they've also included this observation column. So looks and smells smoky outside, gets smokier as, smells getting stronger, things like this. So adding in these additional pieces of information can help corroborate the numbers that they're seeing. And just another tip here is that, if students are having a hard time deciding between showing a graph versus showing a table, and there's really, well, if they're having a hard time deciding between the two, sometimes it's good to err on the side of showing the graph. It's really helpful as an audience member to look at a graph. You can see what the y-axis is, you can see what the x-axis is, and you can immediately see data trends or, how the data is behaving. Whereas if you look at a table, sometimes it takes you a longer time to sort of digest the information and figure it out. So one tip is, if they're having a hard time deciding between the two, sometimes it's best to err on the side of using a graph instead. Okay, and then conclusion section. So as you can imagine, this is where they'll want to summarize in just a few bullet points what the main findings were, or what they think the main findings were of their work. And also this is where they could mention if their hypothesis was, if they proved it or if they disproved it. And I think it's really important to encourage them that even if their hypothesis was found to be incorrect, that's completely okay, because that's how science works. Whether you prove what you set out to prove or you disproved it, you've still learned something, and I think that's really important. This is also a really good place to list out any changes that they would make if they did this again, or how they might build on the work that they did in the future to expand their experiment. So all those types of things could go into this section. And then we have an acknowledgement section. So science posters, they often have these. It's where people who aren't listed as authors on the poster are thanked for their contributions. So for example, you can see that the students in the sample poster, they thanked someone for helping them to design the experiment. And then there's another person who they want to thank who drove the car for them. So those people aren't listed at the top as authors, but they still wanted them to thank them. So that the acknowledgement section is a great place to do that. And then finally, the last section, but also a very important section on the poster is the references. So if students used a picture or a fact, some sort of statistic or a map or something in the introduction or anywhere throughout the poster that came from a website or a book, a report, anything like that, this is where they can cite those sources. So it's a small section at the bottom of the poster, but it's really important to make sure that they cite the sources where they're getting their information and their images from. Okay, so that in a nutshell is the end of the different sections that are included in the template that could be included in the science poster. But I wanted to give you also a slide with the main resources that you'd need to implement this sort of work in your classes. So the first link is the location to download the template and the sample poster again. And then the second link is the direct link to the poster instructions that students can use to help them as they build the poster. And then one idea here is that if students are performing their experiments in a group, is to maybe if, putting an entire poster together for each individual student seems overwhelming, which I can imagine it does, having each of them work on one section will really help lessen the load on any one student. So having them sort of, work together on the experiment and then work together on the poster is a great way to go about doing this. Okay, and so now I'd like to advertise our first annual virtual air quality science fair that's coming up at the end of May. So what this is an opportunity for you and your students to submit a science poster to us. So if your students run an experiment and you create a science poster, you use the template that we've put out there, you can submit it to us between May 3rd and May 24th, and we'll upload them to our site to showcase them, to showcase the work that your students have done, that your school has done. And then we'll do a judging during the last week of May, and the winners will be announced on June 4th. And so we'll be posting more information and updates on our news page on our website, which the link is at the top of the page right here. So keep an eye out there for more information on details and where to submit them to. But maybe the most exciting part, especially for students, is that there'll be cash prizes. So really encourage your students to, do their best work, and they could win a cash prize, which is awesome. And if you aren't already doing this, feel free to follow us on social media, as we really quite frequently are posting project ideas, sample data, information on how to link current events that are happening, such as like wildfires or Saharan dust episodes, to the Kids Making Sense activities that you might already be doing in your class. So making them really more current and relevant to what's happening in the world around you. We also post information on future opportunities and webinars as well. So check out any of the social media channels that we have going there. Okay, and with that, I'd like to thank you for your attention and for attending. And please, if you have any questions, we're going to do a Q&A right now, but if you have any questions after the webinar, please feel free to send me an email or anyone on the team an email, and we'll be more than happy to help you with whatever the question may be.